session if we don't start half an hour late. So welcome to the event that everybody has been waiting for rump session. So I am Nadia.
I am Paul.
And your co-chairs. Paul is for some reason wearing a hat.
Well, Nadia, I'm glad you asked. There's two reasons why I'm wearing this hat. The first is to protect my delicate skin from the blinding brilliance of the rump session talks that we're going to have tonight. We have maybe the best rump session program in the history of this conference or any future conferences. The second reason is if you're a speaker and you need to ask us something during a break, you can find me very effectively because I'm wearing really an absurd hat that stands out from the crowd. So I'm wearing this ridiculous hat and embarrassing myself for all of you. So why don't you give me a round of applause, everybody, right now? Thank you. Thank you. Really, I'm selfless. I'm selfless. Thank you.
Okay, so we have interstitial slides that have the name of the talk and the speaker. We will put the first one up. It will look something like this. So if you see your name as next up, please make sure that you are ready to come to the stage next after the talk. The program is online. The times listed are now a complete fiction, but we will deal with that. So take a look at the program online on the website if you want to know what's in store for tonight. So announcements.
Yeah, we're gonna be having a few remote rump session talks at the very end. So look out for those. We're going to be having 4 breaks. They're listed as 15 minutes. They're probably not going to be that time limitations, but we will announce the breaks. And if you are a speaker and you start to go over time, I have a little machine that's going to make a very annoying noise that you're going to recognize as being your signal to sort of wrap it up. So look out for that.
And as you've seen, physical violence is not out of the question. So can we get our first speakers up to the stage? And yeah, take it away.
So thank you. We at NIST usually give a little update every year, so we'll just run through that real quick. Meltem and I will do that. So starting off, most of you are probably aware of the post-quantum crypto standardization project. About a month ago, we announced the algorithms that were selected at the end of round 3. So in the public key encryption or CHEM category, we selected Crystal's Kyber. And for digital signatures, we selected Crystal's Dilithium, and also Falcon and Sphinx Plus. We advanced 4 algorithms to a 4th round. They were all chems, Byte, Classic McLeese, HQC, and Psych. In the words of Ward, Psych was discovered to have a disadvantage recently, that its security might not be as good as hoped for. We did not advance any signatures to the 4th round because we are going to do a new call for signatures for post-quantum signatures. You can read our report for the reasons and rationale for our decisions, and we've got a great PQC forum. If you ever need entertainment, go to the PQC forum. So here's our timeline and what's going on in the future. First off, we still anticipate having the first PQC standards by 2024. That means we will put out a draft, we will get public comments, and we hope to publish them by that time. We'll hold a workshop on these dates, end of November, start of December. It'll be a virtual workshop. The deadline for submissions for that will be September 15th. And the 4th round will continue on with those 4 chems being evaluated. And we will soon have out, hopefully by the end of this month, a new call for more digital signatures for complementing the ones that we already have. Luis is going to talk about this in the next one, so I think we can skip this. And
Okay, the next project we're going to talk about is the NIST Lightweight Cryptography project. So far, we have 10 finalists, and we are hoping to announce the winner of the process by the end of this year. But to give the finalists a chance and an opportunity to provide some updates, so we're going to we are asking for optional status updates from the submitters, and the due deadline is September 3rd. And this is our timeline, and if you break these algorithms, please let us know before the before we announce the winners. And another project that we have, NIST initially started officially periodic review of its standards and guidelines. And we frequently ask for public comments, so if you can check our websites, that would be great. And we have one review that I want to highlight is about the secure hash standards that specifies SHA-1 and SHA-2. We want to disallow all uses of SHA-1, including the ones that requires just preimage resistance. And you can check other proposed decisions for other standards in our website. And we have 4 upcoming standards. And the first one is the digital signature standard, which has been in draft form for over a year. And it is in the final stage of publication. In 108 recommendations for key derivation, we have a new revision coming up that adds KMAC-based key derivation function. And for random number generation, we are about to publish the 3rd draft of 90C, which proposes 3 different RBG constructions, random bit generator constructions. And to support this 90 series, we're going to have a new technical report that describes how we make some of the assumptions. Thank you.
Hello, everyone. My name is Luis. I have to start by saying that I'm a foreign guest researcher at NIST, an employee, a contractor from Strativia. I'm very glad to finally be able to announce that we will have an upcoming NIST call for threshold schemes. It will be a great exercise for multi-party computation, distributed systems, and other techniques. The scope of this call includes a number of NIST-specified primitives, namely primitives that are based on keys. These include signatures like ECDSA, DSA, and RSA. This includes public key encryption schemes like RSA as well, AES as a block cipher, and also some primitives in elliptic curve key exchange. Threshold schemes basically enable the operations of these schemes when the secret key is shared across multiple parties. So in this upcoming call, our intention is to basically create a basis of schemes submitted by the community that will allow a period of analysis by the public. We intend to call for specifications of system models that make sense for applications in the real world. We intend to call for security formulations. This may include simulatability setting or game-based formulations. The submissions would include a protocol specification, and also very importantly would include reference open source implementations, and of course a security analysis that would prove security. We have a high interest on modular descriptions and implementations, namely because there are building blocks that are likely to be usable across multiple schemes. And ideally, this will support us in formulating future guidelines and recommendations. A point of interest is that we are not intending this to be a competition to select a particular protocol for standardization. Just a quick notes on some technical aspects that are of relevance as we are preparing this call and as we are preparing criteria. One notion of interest is interchangeability. So we are looking for threshold schemes that can be used as a drop-in replacement for conventional schemes with respect to some subsequent operations. For example, with respect to signatures, we would like a threshold signature scheme that can be verified by what is already the conventional verification algorithm. With respect to that, I would like to call your attention for a particular report that we have out since past Friday called Notes on Threshold at DSA and Schnorr Signatures. It's draft IR 8214B. We have, for example, an interest, again, with respect to signatures on strong unforgeability, for example, as compared to regular unforgeability. There are some technicalities, for example, with regard to criteria on how to specify. We want to ask some kind of adaptive security against adaptive corruptions. It's technically challenging to really formulate what we want, considering that we know some difficulties that exist, for example, in the simulatability setting. And of course, the implementations that are going to be submitted, they should indeed implement the threshold scheme. So some aspects that sometimes are left abstract in papers, we're actually going to see how they are going to be resolved. For example, how do the parties actually agree on the message to be signed? Who are the subsets of participants that are going to participate? In a concurrent setting, how do you define session IDs, etc. So in conclusion, we are aiming for guidelines and recommendations. We believe that various stakeholders beyond this community will benefit from guidelines and recommendations. In particular, these could include the to-dos and the to-don'ts, so best practices and pitfalls that we will likely learn across this process of analysis. We believe this will enhance our understanding of techniques and the rationale for the schemes. And we believe this will also enhance the access to reference material by the community, by the larger community. Collaboration by the community is essential. If that doesn't happen, this process will not have effect. Please stay tuned. We will very soon, possibly still this month, announce some steps for feedback and participation. Some timeline was in the previous slide that wasn't shown. Let me just point out that the actual call would likely come only in early 2023. And before that, we will have a prototype call that will go out for public comments. So you will have opportunity to say, what do you think makes sense with respect to criteria and other aspects? Thank you very much for your attention.
Awesome. Hi, everybody. I'm Hart. Unfortunately, I'm a terrible singer, and I don't have an exciting cryptocurrency opportunity to tell you about today. So I'm going to talk about practical problems motivated by. So a little bit of background. I work for the Linux Foundation, which is essentially a nonprofit that hosts collaborations between companies on software. You're probably aware of. Thanks, Nadia. You're probably aware of the Linux kernel, but the LF is huge and behind some of the most open source critical projects in the world, some of which you probably use every day, don't know about it. So just to give you an idea of the scale, even the blockchain stuff that I work on, has a huge amount of contributors, code, and just a lot of stuff going on. So the main point, I think, is that, we see a lot of people and companies implement cryptography and cryptographic applications. And so, we get a really good picture of what people are doing. And so today, very briefly, what I wanted to talk about is what cryptography or cryptographic adjacent technologies have received sort of, a really big push and interest from industry, but very little research from the academic community. And I think these are really interesting spaces for future research. So one thing that I want to talk about today is called self-sovereign identity. Have people familiar with this? Have people seen it? No, a few people? Awesome. So vaguely speaking, it's a term used to describe the concept that an individual should own and control their identity without sort of intervening administrative authorities. So if you want to prove something or show something about yourself, you can do it directly. This is really popular. I mean, even the government of British Columbia has a platform for registering and managing business licenses. They care enough to have several government employees working as full-time open source maintainers, which I think is really cool. And if we go back to the hype diagram, which was mentioned in the keynote yesterday, decentralized identity is really hot right now. It's a very complicated ecosystem. There are a lot of difficult concepts, and there are lots of tricky crypto problems to be solved. So lots of things in zero knowledge proofs, lots of things about privacy and how to avoid correlation between different times when you use your credentials. And the problems here may be solved in theory, but they still need theoretical advancements in order for many use cases to be practical. There's already a huge community around self-sovereign identity. hundreds of people attend these biannual workshops. There's a huge amount of people that want to build this, that want to develop this. And at the last IAW workshop that I attended, there was only one rather mediocre cryptographer that attended. And as you might imagine, this has sort of caused huge amounts of problems for the space. So this is an excerpt from Dan's paper. I think I saw him sitting over there. But sort of having your system be vulnerable to a BLS rogue public key attack is sort of a rite of passage in the space. We've seen it and we'll probably see it again. What is privacy? Defining privacy can be hard for experts in the best of circumstances. And in these credential systems, well, we're not even going to get there. This is, of course, assuming that you actually define privacy or know that it should be defined. And in practice, we tend to see what I call the Patches O'Houlihan cryptographic strategy, which is kind of just to throw tools at the problem until people stop bothering you about it. So what does this mean for you? You know, if you think about these problems, there are lots of opportunities to do research with a big and practical impact. And there are lots of other problems with similar issues too. Interoperability is one. Consensus is another one. There's, you know, excellent work by members of this community. I'm sure you're in the audience today. But there seems to be this attitude in industry that, well, you told me not to roll my own crypto, but you didn't tell me not to roll my own consensus. And of course, anything related to key and data management. So on that note, you know, I'm done, and I hope there are funnier rump session talks in the future. Thank you for your time.
Hello, everyone. My name is Daniel, and because this talk, some people are with me in Zoom, I hope they can turn on their video for this. Okay, they leave me alone. Okay, that's good. So we see Sophia, and I know we also have a couple of us. So we want to introduce, so they can see you indeed, guys. We want to introduce Crypto Latino, which is a group that advocates for cryptography research made by and for Latin Americans. So what are we? We are a community of Latin American cryptographers, and we want to strengthen the community of Latin Americans working in cryptography and also help students and people who want to get into the field. We want to do research that is unique to a region, and we also want to contribute and help back in different ways. Now, who are we? We are a group of PhD students, postdocs, professors, and in general, researchers from the area. And we have a working group. We've been meeting regularly over Slack since October 2020. We hold, as of today, regular meetings bi-weekly, and we also ran a successful workshop last year where we got the community from Latin America together, and we got to show some of our work to students and also people who want to get involved. So this is a small overview of the main team who meet regularly. A lot of names, among them we have researchers, postdocs, even professors, and people in both industry and academia. And it's more than that. In our group, we have about 80 people, and we have like a list of what people are researching on, what their interests are, and we try to keep track of each other and know where the community is. So where are we at the moment? So I am here, but as you can see, Sophia, Abdel, Octavio, they're not here with us. And this is because even though a lot of us had accepted papers, they couldn't make it. And it has to do with things that are related to costs of coming, but also visas. And to get into that, I want to mention that this is the map of countries that don't need a visa to come to the US. And well, the whole Latin America basically is, we require visas. And this is not a problem unique to us. There are a lot of nationalities that suffer from the same. And just to give you an idea about how bad this is the waiting time in the consulate in Bogota to get a visa. We're talking about a period of 2 years, and this is not a joke. I'm sorry for being like so, being bad news, but like this is a real thing. So we are not here because of this. But this is the type of things we want to advocate for. So what do we do in our group? We want, as I say, to promote students, make researchers from the region more visible, We want to create resources in languages like Spanish and Portuguese that can help people who perhaps don't have a good English level get into the community. We want to create events like the workshop we already ran last year that hopefully give us more visibility and give better opportunities to prospect students. And also in general, we want to build a network that is good for international researchers to reach to in case they want to build talent and to get students and other participants from different regions of the world. And in general, you can get information about the region in these resources we want to build. Finally, how can you get involved as a community? We have a Twitter that we keep quite active where we show different works that we have and similar resources. And also we have a website where we post regularly and a lot of things are still under construction, but we indeed have some resources to show. Now, we plan to build more summer schools, workshops and things. We want to invite you and hopefully you can attend and join us. Finally, please be more aware of these type of problems. That's the first way you can contribute and help us raise awareness about it. And with this, I want to thank you. Thank you.
Thanks. Okay. Thank you.
Can
the
speakers
vice-
please use the handheld mic?
Is it okay?
Yeah.
Great. It's not okay?
It's fine. It's just that speaker should use the handheld mic.
Okay, great. Thank you for that. By the way, the visa problem is really important. So I think I second that. Like we should spend some time thinking about that as a community. So thanks for bringing that up. I am here to talk to you briefly about universally composable, non-interactive, zero-knowledge proofs of knowledge from Sigma protocols in the global random oracle models. And this is joint work with Annalise Sanskaya, starring straight line compilers. So here you can see our handy Extractomatic 5000, which takes a proof as input, produces a witness as output with none of that pesky rewinding. We have two different versions of the global random oracle, the observable version and the programmable version, and or protocols, which allow me to either prove that I know how to get UC NISIX or I know some magical trapdoor in the sky. So before we get into the results, you might be asking, why should I care about this problem? Well, we have all of these nice protocols that are based on zero knowledge proofs. And they have proofs of security in the random oracle model. Yup. So naturally, you might be saying, well, these seem pretty useful. We should use them in practice. Makes sense to me. However, realistic settings such as parallel composition and sharing a common setup are very tricky. So this is where you run into problems with rewinding and forking and difficulties in writing the proof. So that's a theoretical problem. And there are corresponding practical attacks on these systems, like the ROS attack that will allow provers to forge proofs. So that's not so great. But we can solve those problems and make our lives a lot easier using universally composable proofs in the global random oracle model. So we show first to draw an implication between UC proofs and some properties that you might expect them to have, such as completeness, the non-interactive version of zero knowledge, and the non-interactive version of simulation soundness. And it turns out these properties are attainable using a straight line compiler. So we can take any Sigma protocol, almost any Sigma protocol as input, to the straight line compiler, run it through, and get a UC proof as output in the programmable global random oracle model. Now, if you're not okay with programming your global random oracle, we also have a construction in the non-programmable version, which takes a straight line compiler again, and also additionally a CRS over a sampleable hard relation. And then you get a UC proof of an OR statement in the observable non-programmable model. So what are some takeaways from this work? Straight line extraction seems pretty useful, and I actually saw it used a few times today, so that was really nice. Not only for the UC model, but also in the quantum random oracle model, because rewinding is tricky there because of the no cloning theorem. And just it will make our lives simpler and easier when we're trying to prove things, so we don't have to rewind anymore. Second, the global random oracle model is weirder than usual. There are some weird session-based privileges in there that come up. So if you are interested in talking about either of these things, I would love to talk to you. And if you want to check out our work, you can look at the ePrint. Thanks so much.
Hello, is this the right microphone? Awesome. Let's see, how do I advance slide? Arrows, spacebar? Ah, here we go. All right, the LLL algorithm. We all know it, we all love it. It's fast, used everywhere. There's a gazillion implementations, C++, Rust. There's even a hardware implementation that someone put on an ASIC for 8x8 matrices doing LLL on those. But what if you want the algorithmic efficiency of the celebrated LLL algorithm combined with the readability, maintainability, and usability that you can only get from a several hundred line shell script? Introducing ShellLL, the world's first and probably last pure bash implementation of the LLL algorithm. Now, when I say pure bash, what exactly do I mean? I mean no sed, no tr, no awk, certainly no Python. This is entirely with shell built-ins, so you don't need any pesky execs anywhere. What do we have implemented? We have Gram-Schmidt orthogonalization. We have projection. We do not yet have LLL. It is work in progress. We're nearly there. So let's do a demo, because this is, after all, the rump session. We're going to do Gram-Schmidt orthogonalization on the following matrix that I'm sure all of you recognize. And so the submissions had to be in PDF format. PDFs don't have arbitrary code execution, except when you don't want them to have arbitrary code execution. So we're going to pretend a little bit, but I promise you this actually does work in a terminal. So this is a shell script after all, so we can just source it rather than running it. And now we have some handy functions available to us, such as Gram-Schmidt. We're going to enter in one vector per line separated by commas. And voila, we have what I'm sure all of you can immediately verify in your head as the correct Gram-Schmidt orthogonalization. Now, what's going on with these colons here? There is exactly one numeric type in bash, which is the signed long. We don't have any floats. These are rational numbers. The first thing separated by a colon is the denominator. So where do we go from here? Well, we need to finish the implementation. We have Gram-Schmidt orthogonalization working. We just need nearest plane, and that's basically all you need for LLL. So we're most of the way there. There are a lot of bugs, though. In the partially implemented nearest plane, we don't have big ints or big rationals. So again, signed longs. Anything larger than the 5x5 matrix you saw, likely to cause overflows. And of course, this is bash, so there is almost certainly arbitrary code execution everywhere. And this does use some bash-specific features, such as array variables. It'd be nice to get rid of those so we could be work on POSIX standard SH. Maybe Perl or COBOL extend to some other languages. There are also a few open questions. First and foremost, do we have too many or too few L's? And of course, the largest question of all is, why on earth would anyone implement this? However, if you are interested in helping with implementation, feel free to get in touch. Thank you so much.